BluntCut MetalWorks, June 28, 2021. This is Elmax 65 Rockwell, sharpened with an edgepro at 15 degrees precise. The finishing edge 600 grit diamond plate, and this is very old, very thin phone book paper, sharp. Thickness behind the edge is 13 pounds or 0.33 millimeters. So anyway, we'll do quick some tests here, and some of these things it can be. Anyway, standard. Check and make sure that it can do basic 2x4, just soft wood, just some dry eucalyptus. A 15 degree precise Elmax have 19% of carbide volume. It's quite high, so and a 65 Rockwell, of course. And come on, and the cut over. Nothing out in the front. It just didn't hit the front, so this is the part I chopped. And this is the Argentine Lignum Vitae here. Most edge at 15 degrees precise will not able to chop this hardwood. The Jenka hardness is about 3,700 foot-pound. I mean, yeah. So it's very. Well, actually, that no. Anyway, it's very hard. So expensive wood I chop, so there are a lot of deflection. But you know, there's a risk of buckle the edge, then I risk in that rather than wasting a lot of wood. There's some hesitation, but again, there are a lot of it, the wind. Let me clean it though. I do not see reflection. So, and I think a lot of times this breeze here make it difficult to tell. The wind just didn't pick up before. Little hesitation. I will take picture of the worst part. I can see that the edge move a little bit. It deflected a little bit, but then but not reflection, light reflection if I looking at it, not this way. We see how this does. Chopping 16D now. It's so more going through. I didn't chop hard enough. Right there. I'll chop a little harder. That that damage right there. That is just a bad thing to do. But I want to see, actually sort of want to see what will take it to chip. I will chop another one. Unfortunately, I chopped the wire instead. Okay. It's at an angle right now. So, a quick close up of the edge. Here the last chop, and have a little bend, and here old bend, and also along the edge here I hit the anvil, and they got a ripple here. They are dented and dented, all bent on the other side. This is the one I keep pounding on it, and the shock wave, and you can see that finally it's, let me look at it. Okay, look like finally chipped, because again I want it collapse. If I keep pounding on it, it would chip, and you can see the deflected toward you now. You can see the reflection toward you right here. 1, 2. So I will take a close picture of maybe this one right there. This is the first chop out here. Here the initial edge at 600 grit diamond plate finish. It's fairly clean. And you can see the, again, thickness behind the edge is 13 thou here, or 0.33 millimeter. For the scale here is 0.5 millimeter right here, so you can see this bevel is not very wide. And chop Argentine Lignum Vitae here, you can see there are a lot of deformation. You can see it bend toward you and away from you, and you can see the color, I mean whether it's bright or dark. Chopping the 16D nail and the one I point earlier, and you can see these are deformation here, near the front and here the back side. And again, these a lot of deflection in terms of deformation, and no sign of fracture. I draw a line from here to here, and then up the height. I calculate the thickness where the point of this bend right here at 47 10,000 or 0.12 millimeter. For comparison with the MagnaCut 65, also, I mean, with same geometry actually, I mean, coincident, and also coincidentally, the magnitude, I draw a line over here and height, and the thickness where the damage occur, also the same thing as Elmax at 47 10,000 or 0.12 millimeter. Does it mean Elmax as tough as MagnaCut? Actually, no, because in the MagnaCut test, they didn't suffer a big chip, and also this kind of rippling here, it actually showed better stability than the big steer off color here, because this will lead to a bigger deflection, and then when you get to the thicker cross section, it will chip out, and that's why you see actually big chip. MagnaCut did chip from some sort of previous test or something, so that's why. Let me see. Of the two, Elmax is not say less than half toughness of MagnaCut. That's not so here, but MagnaCut is. I think this is a better pattern right here, and also it didn't bend exceed this height. Wow, this thing, I feel that in order to fix this edge right here, I have to grind up probably at the at shoulder or even a little higher. BluntCut, I can probably grind up right here, a little bit less, so the extent in order to restore the health of the edge, the apex, the magnitude, I mean, of the correction. The BluntCut is slightly better than Elmax. And here the Elmax with the chip, the big bad chip from when I keep repeat pounding on them, and that chunk come up, but you can see some of the deformation here. Basically, it looked like that anything bigger, or maybe impact bigger, and then they can initiate a crack. And that crack, instead of going to a big half moon, the crack is actually not so as bad as as a 65 Rockwell Elmax in conventional would sell. If a conventional, if you do this, I think the crack probably go up toward the spine, or at least a half moon, big giant half moon chips. So at this point right here, the actual come clean up is 38,000 or almost a millimeter thick. And where this is a crack line right here, actually a crack line to go somewhere like this. So that's why I put the arrow here at 43,000 or 1.3 millimeter. That height of loss is 86,000 or about 2.2 millimeter. Thanks for watching.